A very good day to all. I again hope all to be well and to be pushing as much as they possibly can with regards to the mathematics. So now, gents, I would like us to consolidate on the work that we've been doing with regards to the exponential function. So now I would like us to look at the problems associated with the function itself. So now remember that the general form of the exponential function would be represented by this equation over here. So now the problems that I would like us to look at would be typical problems that you should find in an exam paper. So now, gents, we'll just talk about a few things before we go into the questions that I've prepared. So now, firstly, gents, remember that the horizontal asymptote, so I'll just maybe abbreviate it as HA, so that's the horizontal asymptote. So now the equation of the horizontal asymptote will always be y equals q. So now remember that the q that you will be referring to would be this q over there on the equation. Also, very, very important is that when you have the graph itself, so let's say that you've drawn the graph, so there's the graph over there, and you have some sort of an asymptote over there, you can essentially define any point on the graph. So now what I mean by that is every point on the graph can be represented by the equation. So the equation that you would have used to sketch the graph, we can essentially represent any point on the graph. So now what this means is if you have a certain point, you can essentially find any of the unknowns. So let's say the unknown was A and you needed to find A. It means that you can use any of the points on the graph to find what A would be. So now another very important thing that I would like us to just chat quickly about before we go to the questions themselves is when you have 2 points, so we can just maybe call them point A, as well as point B. So now remember that it takes 2 points to form a line. So now in that line, you can find the gradient. So remember that the gradient or the average gradient of a straight line would be the change in y divided by the change in x. So now remember that this would just equal yb minus ya divided by xb minus xa. So now remember that consistency in this case would be very important. So now that's what I wanted us to just quickly chat, talk about before we tackle the actual problems. So now I'll just move on over to the next page for us to be able to tackle these problems. So let me just move on to the next page. So now given, so that would be the problem itself, given f of x equals a times 2 to the power x plus 1 plus q. So so that would be that equation over there. The line y equals -2 is an asymptote to the graph of f of x. P is the y-intercept of f of x, and t is the x-intercept of f of x. So now on the graph, so we've already sketched the graph that that describes the problem itself. So now t, so that's t over there, would be the x-intercept of f of x, and p would be the y-intercept. So that would be p over there. So now, gents, we've also been given the horizontal asymptote, which is -2. So now let's move on to the questions themselves. So the questions here, 1.1 wants us to write down the value of Q, and it's only just the 1 mark. So now to write down the value of Q, we would go back to the diagram as well as the problem stated. So now the asymptote here was recorded as -2. So we can then just write 1.1. So maybe let me just write 1.1 over here. So 1.1 would then just be y equals q. So we can then say that the equation itself would then just be, so that would be this equation over here, would then be, so let's just 1 second, 1, 2. So this would then be y equals a times 2x plus 1 minus 2. So that would be after we've substituted in the q. So now 1.2 says that, or rather asks, if the graph of f of x passes the point, so that's the point over there, -3 is to -3 divided by 2. So that would be the point on the graph itself. So now it wants us to calculate the value of a. So now a in this case would just be the only unknown. So we can then just sub in the point itself. So that would be the y as well as the x to find a. So let's do so. Let's do so on the next page. So I'll just rewrite the equation. So that would be a multiplied by 2 x plus 1 minus 2. And we've been given the point -3 is to -3 divided by 2. So that would be the point that we would have been given. So now to solve for a, we would need to sub in the point. So that would be -3 divided by 2 for the y. A multiplied by 2. The x would be a -3 plus 1 minus 2. So now we can then maybe just simplify the one side. So we will move the -2 to the left-hand side. So this would be a -3 divided by 2 plus 2 equals a multiplied by 2. So now the -3 plus 1 would just be the -2 over there. And the left-hand side would simplify to a half. So now we can then end up with an a multiplied by. So now the 2 to the -2 should then simplify as, so that's 2 to the -2 would actually simplify to a 1 divided by 2 to the power 2, which simplifies further to a 1 divided by 4. So now that would then just be 1 divided by 4 over there. So now to solve for a, we can firstly multiply both sides by 4. So that would be to get rid of the 4 over there. So now multiplying the right-hand side with the 4, would have the 4's cancelling out. So we should then just have a, and the left-hand side would then just give us a 2. So therefore, a would equal 2. So now that was what we were asked to find. So that was 1.2. Let's then move on to 1.3. So now 1.3 wants us to calculate the average gradient between the x-intercept and the y-intercept of f of x. So now remember that the x-intercept will give you a point. The y-intercept will also give you a point, and you need to find the average gradient between those 2 points. So now let's firstly find the x and the y-intercept. So remember that we now have our equation. So maybe we should have confirmed the equation. So the equation would be, after finding a, would be y equals the a would be 2 multiplied by 2 to the power x plus 1 minus 2. So the equation has indeed been found. So now 1.3 wants us to firstly find the y as well as the x-intercept. So let's just have the equation itself. Y equals 2 to the power 2x plus 1 minus 2. So now for the y-intercept, so we will have the y-inter. So we would need to let the x to equal 0. By doing so, we will have y equals 2 to the power 2, 0 plus 1 minus 2. This then would simplify to a 2 times 2 minus 2, which would of course just be a 4 minus 2, which would just be 2. So the coordinates of the y-intercept will then read as 0 is to 2. So that would be the coordinates of the y-intercept. So now for the x-intercept, we would need to let the y to equal 0. So now this would then just be 0 equals, so that's the x-intercept. So we will let the y to equal 0. So this would be 2 to the power 2 x plus 1 minus 2. We can move the 2 to the left-hand side. So that would just be a 2 equals 2 to the power 2. And actually, maybe before we do that, we can actually say that since we are working, so we are working with the same base, so we just need to add the exponents. So this would then just be x plus 2. So now the left-hand side will have 2 to the power 1. The right-hand side will have x plus 2. Since we have the same basis, we can ignore the basis. So we just have the 1 equals x plus 2. Therefore, x would just equal -1. So now we can then just rewrite the coordinates of the x-intercept as -1 is to 0. Now, once we've done so, we have the, I'll just maybe change color on this. So that would be the y-intercept as well as the x-intercept. So we essentially have two points in which we can now find the gradient, which is what we were asked to do. So now remember that the gradient of any straight line would equal change in y divided by change in x. The reason why we are using this equation over here for the gradient, even though we have been given an exponential function. So remember that this in itself is an exponential function. So now we are more interested in the average gradient between the two intercepts. So that's the x and as well as the y-intercept. So now we are essentially treating the distance between the two intercepts, or rather the two intercepts, as a straight line. So we've essentially drawn a straight line in them. So maybe let me just demonstrate a bit. So if we had to draw a straight line here, so I'll just maybe use the red. So if we were to draw the straight line here, what would its gradient be? So that's essentially what the question wants us to find. So now let's do so. Let's do so. So now to do so, we would again just use the gradient. So that would be y1, y2 minus y1 divided by x2 minus x1. So now this would be, we can choose this to be 1 and this one over here to be 2. So now we can then just y2 would just be 0 minus y1, which is 2, divide by x2 would be -1 and y x1 would just be 0. So that would be -0. So now this then simplifies to a -2 divided by -1, which would of course just be 2. So now the gradient between the 2 points that we've just calculated would essentially just be 2, which is what the question wanted. So now, gents, that's what I wanted to share with you today. Please do go through the vid properly so that you may be able to attempt the questions that do follow. A very good day to all.